of cards because I got to deal these cards out, right? I'm going to deal them out, and then you're going to be able to pick some of them and do it. So I'm going to say using deck star deck. Okay, so there's an initializer. And of course, to do that, I need to import deck. All right, so that's pretty good. Start there. What else do I need for my game? Well, it's a game, so I think it should have a score. We'll say NS integer score. And again, NS integer, NSU integer versus unsigned int is kind of a style thing. I used NSU integer above. I'm going to use NS integer to be consistent here. And my score could be negative, possibly. So that's why it's not an NSU integer. It could be negative. And notice I made this property read-only. It's the first time we've seen that. And why is that? Well, that's because I'm the game logic. I get to determine what the score is. Nobody can set the score. I tell you what the score is. Therefore, there should be no setter for this property, at least not publicly. You're going to see in a moment, privately, we're going to make this read-write so that we can set it privately, right? Because we obviously need to be updating our score all the time as people flip these cards over and get matches, they get points, we need to update it. But publicly, we want it to be read-only, okay? The only other thing I need to do is someone's going to be clicking on these cards. They're going to be flipping over and being chosen and possibly matching. So I need some sort of method to let somebody choose a card. So I'm going to call this choose card at index. NSU integer again, index. So there's a lot of ways, an API you could have for letting someone choose a card. The person who creates this card matching game, not the person, but the other object, like a controller that creates this model class, knows the count because it specified the count of cards. So it's pretty reasonable to have them specify an index between 0 and this count minus 1 anytime someone chooses a card. Okay, so this is just a simple way of specifying which card did the user choose. And similarly, I actually need to be able to return a card at a given index. And why do I need this? Well, I need to be able to find out the state of the game at any given time. I mean, how is my controller going to display a UI for this game if it can't, if it can't find out what the state of the cards is? So this is just a way for it to get the cards. And it could iterate through all the cards and get them all and update them all, or it could get one at a particular index and could kind of, whatever fits best what we're doing. All right, so that's my public API. Now before I go and do my implementation over here, you can see that I got this warning right here. And what's this warning saying? It's saying, there's actually 3 of them. You can click on this little 3, by the way. It's saying you have not implemented these 3 methods that you made public. So that's a good warning. I need to go do that. But before I do that, I'm going to go back to my controller. I want to show you what kind of UI we're going to have over here, so that as we're doing our implementation, you can kind of imagine how they're going to work together. But I actually wouldn't necessarily have to do the UI before I do the card matching game. And one could argue I should do the card matching game first and not be influenced by the UI so much when I'm designing my model. Okay? But this model is going to be served by some UI, so we're going to do them at the same time so you can imagine it a little better. So what do we need for this UI? Well, one thing is we need a lot more cards. Okay, this one card, it can't be matched against anything else. So let's make more cards. This is very easy to do. I'm just going to move this card up into the corner here, and I'm just going to copy and paste it. So I can select it and copy paste. Okay, place it, use the nice blue guidelines there. I can even copy 2 and paste them. Okay, or copy 4 and paste them. Okay. So now I'm going to have 12 cards. That's a good number of cards. I actually don't need this flips thing anymore. I'm not going to be just flipping cards. We're going to be matching cards. I'm probably going to need something for the score, which we'll do a little bit later. But that's pretty much my entire UI. I'm just going to have these cards, and I'm going to click on them. It's going to show a card, and then I could either click on it again to turn it back face down, unchoose it, or I could click on another card, and if it matches, I should get some points, and if it doesn't match, the other one, the last one I had, is going to flip face down. Okay, now those of you who are used to a game like Concentration, it's a little different. Usually you pick a card, Then you pick another card, and if they match, you get points. If they don't match, they usually both turn back over, okay? Which would be a cool UI, but I haven't taught you how to do animation, and that's what you would need there, because that second card, when it comes up, would need to be on screen for a little bit before they both went down, because you got to at least get to see this one. So since you don't have animation, when you click on that second one, it's going to face down the previous one if they don't match. Okay, and then you just keep clicking around, trying to find matches, and you get points. And we'll show you kind of the point system that I'm going to use. So this is my entire UI. It's a very content-central UI, right? The UI is really focused on these cards. There's not a lot of adornments and other stuff around it. And we're really not going to have much other stuff except for the score. And you're going to add like a redeal button and maybe a little bit of stuff about some status about what's going on in your homework. But this is the fundamental basis of the UI. Okay? So now let's go back to our card matching game. And let's talk about how we're going to implement this thing. I'm going to go back to automatic here. Put this thing back. Just to make this look nicer, I'm going to go like that. I'm going to leave this header file up while we go and do the implementation so you can kind of see where we're shooting. This is what we're shooting for. So the first thing I want to do is make this be read-write in my implementation only. And I do that with this little private interface. Remember I showed you about this, that you can have one of these with a little open parentheses, close parentheses like that. And now you can declare your own things. Well, I'm going to redeclare this thing to be non-atomic read-write NS integer score. Okay, now this read-write, we don't use that very much because it's the default, right? Is chosen, remember the properties chosen and matched that are in card? Those didn't say read-write, but they had a setter and a getter, okay? They were read-write. We really only use this when we're trying to redeclare a read-only one from public to private. This is about the only time we really use this. There are probably programming styles where people put read-write all the time, even though it's the default. Some people do that with strong, since strong is the default. I like to specify strong everywhere, just so it's really clear what's going on in my mind. But read-write, not necessary for most things, except for here where we're redefining it. So everyone understand what I'm doing here? This is score. This is exactly the same score. It's just that this says there's going to be a setter. But I'm only going to be able to call that setter, at least not without a compiler warning, in my implementation, okay, because I've declared the read-write part here. No public person is going to be able to set the score, call set score, without the compiler giving a warning. Okay? So the next thing I want to do is I want to think about my internal data structure for my card game. Really simple. It's just an array of cards. Okay? I'm going to have an array of cards. It's going to be this many cards. I'm going to pull them out of this deck. And people are going to be able to choose those cards. Someone can go look at the cards and we'll adjust the score as people choose the cards. Okay? So I need that internal data structure. It's internal, so I'm going to put it here. Non-atomic strong. It's going to be an NS mutable array. Okay? And this is similar to what we had in DEC, right? And I always like to put of card just to say what's in here, because as we said, there's no way in Objective-C to kind of have the compiler enforce what's in here. The things that are in this mutable array are just objects, and the compiler does not know what class they are. Okay, so it's up to you to make sure you don't send messages to things you pull out of it that are wrong. So here we are trying to at least give the person reading our code know our intent. Our intent is for this to be an array of cards. Okay? And of course, we want our lazy instantiation. Okay? So that's good. So now we have this array of cards. We can use it anytime we want. Again, we could do this initialization in the initializer, right? We could do this alloc init in here, but I happen to like using lazy instantiation. I think it's kind of makes the code in our initializer look a little cleaner. So let's do our initializer next, though. So I'm just going to copy and paste here. You know, probably not necessary to copy and paste, because if you just start typing this, it's going to escape completion. We'll do that with the other method just to show you that one. And then we all know that we do this weird thing here, self equals super init. Now, this is our class's designated initializer. In other words, you have to call this initializer or our class will not be properly initialized. We could have other initializers that could call this one, okay, if there were ways to default things or whatever. There is no way to do that, default it. So this has to be our designated initializer. So I'm actually going to put a comment in my public header file saying this is my designated initializer. That way, if anyone ever subclassed my card matching game, they would know that in their designated initializer, they'd have to call super our designated initializer. Okay, that's the way designated initializers work. You have to call your super's designated initializer from your designated initializer. Question here from.
Does the compiler know that this is the
designated initializer? No, the compiler does not know. This is purely a commented thing. It's similar to this kind of comment thing. It's unfortunate that the compiler does not, there's no keyword or anything that says, this is my designated initializer. You had a question first here. Okay, question.
Is there a way to disable the default initializer if you have a designated initializer which is different?
What do you mean is there a way to disable?
Like you return nil or something like that from the default initializer.
Well, follow up with me. I don't quite understand the question. If you have other initializers, I guess your question is, how do I disable another initializer?
Well, like in many other languages, you can set your initializer, your default constructor to private or something, so that you can't use that.
Right.
But
oh, I see what you mean. Yeah. Okay. So the question is, could I have another initializer, designated initializer, not be public or something, be private, and have things called from? Yeah, you absolutely could do that. Although if you make your designated initializer not public, then subclassers don't know about it because there's no protected in Objective-C. So anything subclassers need has to be made public for them to see it. It's still there. They can still subclass it, but to document it, you have to put it in your public API. So yeah, the whole thing with initializers in Objective-C is less than nicely supported by the language. Question.
Does it make sense to maybe override init to use your designated?
Yeah, so the question is, would it make sense here for me to implement init here, right, to do something? And actually, it might well make sense to override init, and you know what you would do? Return nil. Okay, because if you do card matching game alloc init, it's not properly initialized. And there's no default for the number of cards or the deck, so return nil. Okay, so yeah, so the answer is yeah, you could. All right, so this is back to our designated initializer. We need to call our super's designated initializer, which for NSObject is init. No arguments. Okay, then we just say if self, then we can initialize ourselves, and then we're going to return self. And if anything goes wrong in here, we will set self equal to nil, okay, and break out of this thing. And in fact, something is going to go wrong in here, as you will see. Okay, so what do we need to do to initialize our thing here? Well, we need to pull this many cards out of this deck and put it in our internal data structure here, right? So how would we do that? How about for int I equals 0. I is less than count, I plus plus. So that's just me going through this many of these things. I'm going to say card